everyone, and welcome to this session that will revolve around agent-based and social complexity. We will start with Julian Arevalo that will speak about his paper, Adaptive Readiness and Agent-Based Model of Peace Negotiation. You have 15 minutes?
15.
Yes. Good luck.
3 more.
3 more, okay.
Good afternoon, everyone. Thank you for being here. Thank you for the organizers for the opportunity of being in this space. I want to start by saying that during coffee, I introduced myself to someone, and I said I'm an economist and a political scientist working on peace negotiations. And his question was, and why are you here? So I want to answer that question today, and I hope it makes sense what I'm going to propose to you for this. So I studied peace negotiations. My background in political science at some point was working precisely in peace talks between the Colombian government, I am originally from Colombia, now working in Switzerland, and two different guerrilla groups, FARC and ELN. The story is that in the first case with FARC, we got to an agreement in 2016 with 13,000 people who demobilized, and we started a series of reforms in the country. In the case of the ELN, we didn't get to an agreement. And my question at that time was, why, starting with so similar conditions in terms of the government, in terms of the international context, the domestic political context, and so on, we got to such different results? Then I went back to reflect on things that I had seen in the past about complexity, and I said, well, maybe I can find a good explanation to this outcome in that literature. So when I went to that literature, I found that for conflict resolution, there is a strong emphasis on the structural conditions of the conflict. One of the most important theories in the field is called ripeness theory, which is something that we more or less say all the time when we talk about conflicts like what is happening today between the US and Iran. Questions such as, are the parties ready to negotiate? Are they really interested in committing themselves to a negotiation with what that means, for example, making concessions, having an understanding with the other side, and so on and so forth. And basically the next question after asking ourselves if the parties are ready is, well, if they are not ready, then more likely the outcomes are not going to be good. Or if they are ready, the outcomes are going to be good. As if only those initial conditions and the structural understanding, the structural elements of the conflict could determine the outcomes of the negotiation. And of course, all of us know that the negotiation itself can change the results of the process. So basically, what I'm arguing here is that it's a very simple mechanism in which negotiators have issues that they have to discuss, and depending on the preliminary results that they get, that information feeds back to the negotiators, and now they have another attitude towards the process, eventually. So basically, there is a feedback mechanism that I will explain later. So this is the literature that I was referring to, ripeness theory, ripeness theory, readiness theory, which is more or less the same, but making different specifications for different parties. So one party can be more ready than the other party, for example. False readiness, when parties go to negotiations, but, there is no serious interest in getting to an agreement. And something that I developed in a previous paper in 2024, which is what I call uncertain readiness, which is basically, I want to go to a negotiation, I want to see what happens, but I don't know what the outcomes are going to be. I don't want to trick the other party, but I have not decided that I want an agreement with them. It's only what happens during the process what will determine the results. You know all of this, so for this audience, I don't need to present all of that. So this is the paper that I was referring to and to our supporting papers. And this is the graphic that I use for that paper. Basically, negotiations start, you have the time in the x-axis, then you open the negotiations because of different reasons, readiness, false readiness, uncertain readiness. Parties devote efforts to the negotiation, you get preliminary results and outcomes, and then what we know in complex systems, then you have those feedback loops. So basically, I invest, I get results. The higher the investment, the more likely we get positive results, and that feeds back to our readiness, and that feeds back, of course, to our efforts in the next stages, and so on and so forth. So that was the dynamics that I developed for that paper. So I want to understand how that initial readiness of the parties interact with process design elements, for example, to generate the outcomes of peace negotiations dynamics. I want to say that some of the comments that I have gotten in the past is that I talk mainly about peace negotiations, not negotiations in general, because of this concept that I have been studying, which is readiness and ripeness, are anchored in the peace negotiation literature. So this is my agent-based model. That's a negotiation. So you have two sides, the blue side, the red side, some issues on the table. Blue issues are on the interest of the blue side. So for example, one country should not have nuclear weapons. Red issues are on the interest of the red side. So for example, a given location in the sea should be open. The darker the issues are, the more effort they require from both sides. And they are going to feed back, as I said, to the motivations and general readiness of each of the sides. That's more or less it. Based on that, then you have, this is not the right presentation, but this is, I have another version that is updated, but this is an example of the dynamics of the process in which, in this moment, they are in the discussion of the third issue, and then you can see the evolution of readiness in the panels at that side, at your right. So basically, you start with some levels of readiness, and depending on how the process evolves, those levels of readiness change, and then people are more or less willing to put some effort in the negotiations. This is a nice collection of graphics in which I started multiple rounds of negotiations, starting all of them with the same initial level of readiness for one of the sides, and showing some things that we in this field know, which is that we can have basically any possible trajectory regardless of that initial condition. So we start with that, but we can go like in the green line to very positive results, in the blue line to something around the middle, and in the orange line to a failed negotiation. Based on that, here is again another example, but now using different structures of the game that the parties have to play in every single stage. So I have a more cooperative game in which the parties interact with putting more effort, more cooperative. In the green line, cooperative only in the blue line, and more competitive in the orange and red lines. I did thousands of simulations of those negotiations with changing all different possible parameters like outside options, types of strategies, types of agendas, and okay, this is my simulations, as I said, 800,000 combinations, and I got nice graphics such as these ones. I want to explain this. If you get only one message of this presentation, this is the graphic, or any of those are the graphics. In the x-axis, we have the initial level of readiness of one of the parties. And in the y-axis, the initial level of readiness of the other party. And what we have in the picture, in the graphic, is the probability of success, or I should correct, the frequency of success of those negotiations. So the more red the color is, the more agreements we had with those initial conditions. And the more blue, of course, the less percentage of agreements. So what we have here, to some extent, at the beginning, is a confirmation of ripeness theory. Basically, if the parties are not ready to negotiate, of course, they are not going to get an agreement. Because with lower values, we have more blue, and with higher values, we have more red. So that's not surprisingly. What is interesting is that, as you can see, this is not homogeneous. We have a lot of holes, a lot of irregularities, a lot of patterns in those interactions between the blue and the red areas, which is what makes this so interesting. So for example, when we have the competitive negotiation in the top and the cooperative negotiation in the top and the highly competitive negotiation below, we see important differences in terms of the probabilities of success, or at least solving all the issues that the parties are trying to address. So we see basically in this case a more cooperative approach, I win, you win, is more conducive to agreements than a more competitive approach in which I win, you lose. If we take a negotiation as a more highly competitive, with a more highly competitive approach, then the probabilities of success, as you can see, extend to basically the whole graphic, and basically what we're saying is it doesn't matter how much ready you are or how ready you are to start the negotiations, more likely you are going to fail. This is with the approach to negotiations. Here we have with the types of agendas. For example, I really like the one over there, the cited agenda. In the cited agenda is a strategy that many people use in negotiations, saying we are going to talk to this armed group, we are going to make concessions on the agenda so they are interested in having a negotiation with us, as opposed to having a balanced agenda in which the interests of both sides are incorporated into the process. So basically what we are saying here is the more balanced the agenda is, the nicer in terms of more reds we have as outcomes of the negotiation. So, and I have another one like this with the type of effort that the parties do. Basically what we are saying is if we are in a high effort negotiation in which we are putting effort to find solutions, to find common ground, to build bridges with the other side, and so on and so forth. Or if we are just saying, I'll just come to the table with those positions, and you have to make concessions on all of them. The other side does the same, no more effort than that. Then you have the low effort graphic in the top left of the right for you of the graphic. That's more or less what I have gotten. Then I did some regressions with that in order to summarize some of the results, and I found, of course, the role of those variables related to the strategies determining the effort, the type of agenda, and the type of negotiation as not only statistically significant, but playing a more important role than those variables associated to the structure of the conflict or the initial conditions of it. Let me go back to this, because there is something that I really like. If you go to this graphic here, this is what I can point at. This little point here in 2010 in this graphic in the bottom. What we are saying here is, and this is our reality in the field of peacemaking, we are dealing with parties with very low levels of initial motivation to negotiate, but still there is probability of getting an agreement. So it's not about how the parties get to the negotiation, but about how they let themselves or not be changed with the negotiations. When you hear the news last week and you heard that the parties sat down to negotiate for 16 hours and they didn't get to an agreement, well, that's not surprising if you go with this logic. If you go with this logic, you understand that the parties go to the negotiation, but you require some time, I wouldn't say infinite time, but some time in order to let these feedback loops affect the negotiators and then change the process in which the parties are involved. That happens here. And also, if you want to go to the opposite example, go to 100 almost in the graphic over there, and then you see parties that came with a lot of intention, very good declarations, we want to have peace, but they didn't invest on the process. And then many times happen that even with good intentions, people don't get to any type of agreements like the ones over there. I have tons of examples, but unfortunately, not so much time. But those negotiations that I was explaining between government of Colombia, FARC, and ELN, or for example, 1978 negotiations between Israel and Egypt could be explained by dynamics such as the ones of this process. Right now, what my colleagues and I are working on is on introducing fragmentation within the different parties, because we know that we are not one person negotiating with another person, but delegations of two different sides with different opinions of different sides. And we are trying to model some of those internal differences in opinion, internal heterogeneity, and then we try to address how there is room for some healthy spread of opinions in which we are not completely fragmented, in which basically we will have one extremist of one side of one position and another extremist in the opposite position within the same delegation interacting with something like that on the other side, but also we don't have an echo chamber in which everyone thinks in the same way that I think in my delegation. So we model that, and with this, let me skip this, we introduce some dynamics in which the level of heterogeneity within each of the delegations changes with the preliminary results that I was saying before. So basically, we are still incorporating those that notion of feedback loops, but affecting the spread of opinions within the group. And then, well, we have a lot of interesting dynamics here, but I wanted to show you this before I don't have more time. Sorry, this one, which is very similar to something we had gotten before, perhaps with a little bit more of granularity, but then again, more blue with lower initial levels of motivation here, readiness here, more red in the top, that's not surprising, but look at 45, 45. There's a red dot. So it's very low, initial motivation, but still we are getting some agreement. So there are some internal dynamics here that confirm the argument in which, or help us understand better this argument in which the role of those dynamics is what is determining the outcomes of the process. And then we shouldn't be, and this would be my main conclusion, we shouldn't be very pessimistic about the prospects of a peace negotiation, because that pessimism materializes itself. Basically, if I go with a very low expectation of success because I don't believe in the other side, because I don't trust the other side, then I'm not going to invest the resources that peace negotiations require. That means that we are going to get bad preliminary results in the earlier stages of the negotiations that would feed back to our levels of motivation, making us lower our levels of effort in the future. So basically what we are saying is there is a lot of room for mediation, there is a lot of room for studying the other side, there is a lot of room for working for understanding better, having a better understanding between the parties during the process, and with those changes we can have results which are quite exceptional, like the few peace agreements that we have gotten in the last 30 or so years. I think that's it. There is more information, and I'm happy to discuss with you during coffee, but I want to respect time. Thank you very much.
We will move now to Ms. Remah Dahdoul, who will be with us online, presenting a paper entitled Campaign Spending Driven Polarization Transition in a Double Random Field Model of Elections.
So I can start my presentation for today. So hello, everyone. My name is Remah Dahdoul. I'm a PhD student at Complexity Science Hub and the Medical University of Vienna in Austria. Today, I'm going to present a topic, campaign spending driven polarization transition in a double random field model of election. I know it's a long title. It's a work with collaboration with Jan Korbel and Stefan Turner. And this has been like my first research project at the Complexity Science Hub. Recently, we've been successful in publishing our work at PRL. So if you find this talk interesting, please check it out. So the motivation of the work, like we've seen recently in elections, that there's an increase in political polarization. And we know that there are two components shaping the electoral outcome: the voter homophily and the campaign intensity. Yet it's unclear how campaign spending interacts with social influence among voters. So we asked this question, like, how does campaign spending influence this polarization? So we, as physicists, we just chose a simple physics-inspired model, combining those two factors to look at the interplay between them and to try to answer our question. So in this figure, you see some sort of a picture of how a social network would look like, where we have individuals, or in the context of elections, are voters, interacting with each other. I hope you can see my cursor. And in this network, we have an external influence we state as like the campaigns, external campaigns affecting the opinion of these individuals. So the language of our model, using model with random by model field, we model these individual opinions as binary spins, which can take values plus or minus one. So an individual can vote for either one party or another. So we focus on bipartisan framework. We incorporated this homophily term by the standardizing model interaction term, where here Aij is the adjacency matrix, which will encode the topology of our social network. And we have external campaign given by this external magnetic field contribution with probability B, like a voter would follow a campaign promoting the opinion plus one, and with probability 1 minus B, a voter would follow the other campaign promoting the opinion minus 1. So we have a Hamiltonian describing our system, and we wanted it to be more similar than this. So we introduced the configuration model approximation, where we assume the underlying network is a random graph. So we can approximate the adjacency entries using the degree of the node and using the average degree of the network. We also use the mean field approximation, where you can write the spin value or the opinion as a summation of the average opinion plus fluctuations. And we denote from here to later on this average opinion value as the M, which is equivalent to the magnetization in the physics framework. So by plugging this back to the Hamiltonian, discarding the quadratic terms and fluctuations, doing some manipulations, you get a nice form for the mean field Hamiltonian, where it's easy to track. Sorry. So we have the equilibrium distribution, and we can find the total average magnetization, where we average over the external field, and we get this nice formula, which is a self-consistent equation of magnetization, which would be like the pillar or where we derive everything later on in our analysis. So we also defined a measure of for the polarization, which means we wanted to have some sort of a measure to for the society, whether it is in consensus or polarized phase, by defining this by value, which is the difference between the opinion of groups affected by opposite campaigns. In other words, if this group follows this campaign and this group follows the other campaign, if they both agree on what party they're gonna vote for, pi would take a value of 0. If they disagree, it would take a value greater than 0. And we call this campaign polarization. So again, you remember the consistency equation, we solve it numerically and we get a view of the phase diagrams. In the first row, we have the magnetization plotted in the spinning plane. And in the second row, we have the polarization. So if we have a look at the left corner at the first figure, we see this case where we have a temperature equal 1 and P equal 0.5. What is P? P is the size of the group influenced by the positive opinion, so a positive campaign, sorry, promoting the +1 opinion. So for this case where we have symmetry and for temperature equal 1 and even greater than 1, the phase space looks like this, where we have one stable solution. The color would indicate the equilibrium magnetization value. We see that nothing is really interesting. This translates into the election language that we have the null model, which means that if you spend more, you win, and that's it. If you go a little bit to the right, for lower temperature, slightly lower temperature, we see that this interesting region emerges, which this region corresponds to more than one stable solution for the magnetization. In other words, we have hysteresis. In the language of elections, we call this region as the incumbency region, where the system returns some memory of the past state, and the incumbent can still win even if they spend less than their opponent. So we wanted to characterize this region and find this value here, the critical spending value. If you see the equations below, right below, this is a generalization of how we can find these critical values analytically. If we reduce this, substitute here P equal 0.5, we get the well-known critical curves. Here, we are able to find analytically, let's say, the critical spending value that characterizes this region. And what also it characterizes that after this region, if we look at the polarization plot, we see that there is a rapid increase in polarization from value 0 to it increasing. And this is what we call as a phase transition in polarization. If we look at the plots here, we see what we have changed is that we chose P equals 0.6. What does it mean here? It means for example, for this district where we have the elections, a priori, it's let's say Republican leaning. We see that there is a change of this shape of the phase diagram, but still we have this hysteresis and critical spending value, and when we have a slightly lower temperatures. So we wanted to see how much of this can we capture from real world data? Like, does it really describe what's happening in real world? So we applied our model to US House elections from a period of time from 1980s until 2020. So we focused only on bipartisan races. So all races with more than two candidates and with non-negligible outcome were excluded. So we end up with around 6,400 races. And we adjusted like campaign spendings to inflation. So overall we had like 21 races, including midterms and presidentials. And what the data actually contains, or what it did matter to us, is that we had like a year when did this election happen, and each party's spendings. We had like the percentage of winning, and we had like an estimation for the p-value. So we estimated the p-value from previous election results. So this district has a p-value, let's say 0.6, based on the previous electoral outcome. And the most important variable here of what we had is the incumbency indicator. So this would tell us whether the winner was an incumbent or challenger, or it was an open seat. So in our work, we weren't really interested in building a model that predicts the election outcome as it is. We wanted like a model that describes what's happening. So we thought about like um, having the purpose of the model to be a classifier is good to describe the phenomena. So we focused on our model gives a magnetization value. If it's less than 0, a Republican wins in this like in our construction. Sorry, if it's greater than 0, a Republican wins. If it's less than 0, a Democrat wins. And we interpreted this hysteresis region as the incumbency region, which means, again, the incumbent wins even if they spend less. And we use this like effect of incumbency or hysteresis to calibrate the model and find the parameters of our interest, which are like the temperature and the critical spending value. So this is what we obtained. These are the main results. If you look at the right, figure D, for example, the way we found this temperature is by like having a plot for the accuracy, measuring the accuracy of our model in its predictions against like several temperature values, and then optimizing this and finding like the optimum temperature that would give the best performance. As you see from the plot, like the accuracy is really modest in absolute terms, but like we used McNemar test like to see if it's significant or not. And yeah, it is significant. So it really says that temperature is lower than 1. That's the first thing important. And hysteresis region actually exists. So in the middle plot, as you see here, we can show this hysteresis region, and we can show those cases where incumbent won, even if they spend less than their opponent or their challenger. And we were able like to find this critical spending value, which is $1.8 million. So it's worth mentioning here that this value is for the close races. So to control for the P parameter, we filter for the races where we have like P 0.5. So it's close races. There's a priori no leaning towards any of the other parties. And we have this critical spending value. So then to look at polarization, or to verify whether like our results have meaning or not, you look at the full region of the face space. We took the races where we have close spending. So both parties spend like almost the same on their campaigns. And we track the magnetization value for this. You would see that below the critical spending value, results tend to be decisive. But after this critical spending value, they cluster around the 50-50 results, or in other words, zero magnetization. And like even more than that, if you track like the races exceeding the critical spending value throughout the last 20 years or more, you see that there is an increase pattern of the polarization. So this would lead us like to the end of this talk, where as a summary, polarization phase transition exists. And campaign spending can trigger this, such a phase transition from social-driven voting to a strongly polarized elections. We have hysteresis, and which we interpret as incumbency advantage, like an incumbent can um, stay in the office regardless if the challenger outspend them in the elections, given that they really didn't outspend them, like if keeping that they are still in the hysteresis region. And this is like the nice thing of what we characterize in this work, that this is the region and this is shape. And we had an estimation of the social temperature, which is a nice, interesting thing, and it's a hard task to actually measure. Like, and maybe someone would ask, like, what does it even mean, a temperature here? It would mean like this social volatility or tendency to change your opinion. We were able like to have some estimation for this social temperature, and we tested our model with empirical data, and we found a critical spending value showing that campaign spending dominates social interaction. If you spend more than this critical value, campaign spending dominates the homophily and the social interactions, and polarization increases. So thank you.
Thank you, Ms. Remah. We will move now to Nicholas Roxburgh, who will be presenting on behalf of his team a paper that is entitled Exploring Interdependencies in an Island Economy.
Good afternoon. So this talk is going to be about how small communities are held together, but also sometimes come apart because of interdependencies between people, households, roles, and infrastructure. I just press the green button. So in island and rural settings, socio-economic activity is closely coupled, but redundancy is really quite limited. And external substitutes, whether people or services, are often slow, costly, or simply unavailable. Under these conditions, even modest disruptions can really cascade throughout the system, and they're rarely isolated events. So the loss of a single family, a brief contraction in, say, tourist demand, or the closure of one service can reverberate, affecting multiple other roles and households at once. Crucially, these effects can propagate through second and third order pathways that are difficult to anticipate in advance. And in small systems, these cascades move quickly, and the consequences are felt directly in service continuity, household viability, and longer-term patterns of population stability. Island economies have really all of the features we associate with systems that are hard to analyze purely analytically. First, there is huge heterogeneity in household circumstances, needs and preferences, and in the requirements of roles and infrastructure that they have. This is not just a matter of attributes, but their fundamental positioning within dependency structures. Secondly, there can be strong feedbacks and threshold conditions at play. When a role becomes unviable or a household leaves, that reshapes demand, supply, and viability conditions for others, sometimes amplifying disruptions with repercussions cascading through the system. And third, a substantial share of the dependencies are conditional, only activating under certain states. for example, during emergencies or in the event of ill health. And this means the dependency network as lived changes over time. That combination of heterogeneity, numerous dependencies and feedbacks, and conditional activation is why we really need to use agent-based modeling. It's not to predict the outcomes, but to represent in the structure, the structure of these networks explicitly and explore how these dynamics unfold. Central commitment of the work we were undertaking was to ground our modelling in empirical realities of an actual Scottish island community, rather than constructing a purely theoretical representation of one. And to do this, we worked in partnership with the local island trust that was willing to collaborate closely with us in the process. For privacy reasons and ethical reasons, I can't disclose the identity of that island. Through a series of in-person workshops, we worked directly with residents to identify which roles and infrastructure are present, who performs those roles, and how they're bundled within households. We also collected information on household composition, allowing us to infer certain demographically determined needs, such as the presence of school-aged children. Dependencies between system components were then mapped using expert judgment, with this judgment then critically reviewed and challenged and updated by participants. The result is a structurally faithful representation of a real system, suitable for exploring how the interdependencies shape vulnerability and resilience. Crucially, this isn't a sampled system. The data covers every resident and every locally performed role on the island, allowing us to work with the complete configuration of interdependencies, not simply a subset. Once we started working systematically through the dependency data, one thing became really quite clear. So dependencies take many different forms, and that distinction really matters for what absence actually implies. Some things are genuinely critical. If they're missing, a role cannot operate at all, or a household cannot reasonably remain on the island. Other dependencies are less absolute. Their absence may create strains, inefficiencies, or risk, but not immediate failure. And some only matter under particular conditions, such as emergencies or during periods of stress. To reflect this, we distinguish between different dependency types. For roles and infrastructure, hard dependencies are absolutely required for operation. Soft dependencies allow continued functioning, but with degraded performance. And contingency dependencies may be invisible most of the time, but become decisive in specific situations. In the case of households, by contrast, well, not really by contrast, actually, because the logic is pretty much the same, but the stakes differ a bit. Some dependencies are required for continued residence. Others affect everyday friction and risk. And some are primarily about well-being rather than viability. So we also include, in the case of households, a category of enhancing dependencies, which matter for quality of life rather than immediate survival. This typology is important because it directly shapes how disruptions propagate. Whether loss leads to immediate breakdown, gradual strain, or latent vulnerability that only surfaces when particular conditions arise. With that in place, we can now look at what the dependency structure actually looks like. This is a directional chord diagram. It takes a bit of time to make sense of. It has infrastructure and roles shown around the outside. The presence of an inner track indicates a dependency on another role or infrastructure, identified by where the chord travels to. The key thing here is not so much to focus on the individual links, but the overall patterns. We identified 77 hard dependencies in total, and provision of these dependencies is highly concentrated. a small number of infrastructural elements, most notably, and perhaps not surprisingly, electricity, roads, ferry service, and waste management are depended upon by many other parts of the system. In addition, there are 16 roles that act as hard dependencies for others. Soft dependencies look very different from hard ones. They are almost universal. Most functions rely on at least one. But provision is still fairly concentrated. As with hard dependencies, infrastructure plays an important role, but here we also see many role-based dependencies, with delivery drivers in particular standing out. The key point is fragility here, because a large share of these roles are performed by a single island resident, or many of them aren't performed at all at the moment. Contingency dependencies are widespread in the sense that many functions have them, but provision is extremely concentrated. Almost all contingency dependencies point to a very small set of roles, particularly emergency response functions such as paramedics, on-call firefighters, and mechanics. Here we have our hard household dependencies. These are encoded as operational rules that link household characteristics to reliance on specific roles and services. Each rule specifies 3 things: the proportion of households it applies to, any qualifying conditions, such as the presence of an elderly member or a child in school, and the resulting dependency type on a given function. And together these rules define how household composition shapes demand for services across the system, and they form the logic through which dependencies are assigned in the model. There are 12 hard household dependencies here. They capture cases where absence would make continued residence untenable. For example, access to essential care or schooling. The soft household dependencies are much more numerous. We got 37 in all. Stark contrast, there's just 4 contingency dependencies. Finally, there's 20 enhancing dependencies, and these include things like artist, chiropodist, restaurant, that kind of stuff. Even before building this into a model and conducting simulation, I think the structure is quite telling. A small number of functions stand out as keystones, supporting large parts of the system. But there's also a broader tier of roles that, while less central individually, are still relied upon by many others. And because provision across both tiers can be thin, vulnerability tends to be structural. It's not just sector specific. It arises from how the system is put together. Also important is that the difference in dependency type implies different potential modes of failure. The next step for us is to move from looking at structure to exploring the dynamics. We're not there yet, but we're in the process of using the dependency structures and household data we gathered to construct an agent-based representation of the island economy, one that explicitly links roles, infrastructure, and households through the dependencies you've just seen. This will allow us to explore how the system responds when it's perturbed. For example, the loss of a role, a household leaving, or a drop in exogenous demand for something like tourism. As the simulation runs, roles and households will reassess their viability based on unmet dependencies and changing conditions. I want to close by stepping back from the mechanics of the model and reflecting on why I think this approach matters more broadly. First, the work takes complexity seriously. Rather than simplifying them away, the model treats dense, uneven, and conditional dependencies as a defining feature of how small communities function. Vulnerability emerges from these structures. Second, participation here is not about generating a list of parameters, but about shaping the structure of the system itself. So community members helped identify which roles exist, how they're bundled within households, and the nature of the dependencies. Finally, the model is not intended to predict outcomes. Its value really lies in supporting structured reasoning, exploring what-if scenarios, surfacing hidden assumptions, and revealing potential vulnerabilities before they're encountered in reality. I'll finish by thanking the community participants who shared their knowledge and experience so generously, and the Ireland Trust who made the work possible. And also I have to acknowledge the Scottish Government for funding, backing this project. Thank you.
So now we'll move on to Ms. Saida Hachimi Idrissi and Mohamed Nimish, who will be presenting a paper entitled Formation of Complex Societies, an agent-based model inspired by Freudian theory.
So, hello everyone. I think you can hear me, yeah. I'm Saida Hachimi Idrissi. I'm glad to be here to present our work, Professor Mohamed Nimish and I, titled Formation of Complex Societies, an agent-based model inspired by Freudian theory. So this work addresses a fundamental problem in the science of complex systems. It tries to answer the question, how do human societies transform from small kin-based groups to large-scale anonymous states of today? So, how can I ask that? So the scale problem. So we have in small groups, cooperation is supported by kinship and direct reciprocity, which means there is always a disconnection of of the individuals and direct individuals, and there is a direct reciprocity on giving a hand or a help to someone. However, in large societies, individuals must cooperate with strangers, and this creates a fundamental tension. Cooperation is necessary, but it is costly at the individual level. Without regulation inside the groups, internal competition undermines the group cohesion. So the key question becomes what mechanisms allow cooperation to emerge and remain stable at a large scale. Our essential hypothesis is this sentence: large-scale cooperation emerges through the repression of individual satisfaction, which can be divided into two ideas. So our central hypothesis is that large-scale cooperation does not emerge and arise spontaneously in complex human systems. It emerges specifically through the deliberate repression of individual satisfaction and desires. So social order necessitates limiting individuals' autonomy, which means repressing their satisfaction for the collective benefits of all the group. This limitation on individual freedoms enables effective coordinations and stability at large scale. Our theoretical framework, so we build on two complementary frameworks. The first one was from Freud. We adopted the idea that civilization requires the repression of individual impulses, the thing that Freud cited in his book, in his famous book, Civilization and its Discount. And for evolutionary theory, we rely on Frank's framework, where internal competition reduces group efficiency. And he says that groups evolves mechanisms that helps them to regulate and make the policy inside the group, so so the group can maintain the competition. This will enable large cooperation on the groups, and that will be good for all the groups. So in our model, we interpret this idea by modeling satisfaction as the autonomy of the individuals, and repression is the social regulation that is applied on the groups. This allows us to formalize a psychological concept of Freud within an evolutionary framework of Frank. To implement our idea and to test it, we tried to implement it in an agent-based model. So we used an agent-based model where each agent represents a polity or a society. And the system is spatial, and interactions are local, and no global coordination is imposed between the agents. Large-scale structures emerge naturally, and at the end we can see that large-scale structures emerge naturally from local interactions. So here I represent the environment of our model was the Afro-Eurasian land. The Afro-Eurasian map, it was divided into uniformed cells, and the agent may be an independent polity or a multi-cell polity, which means a larger group. Each agent is characterized by satisfaction, which means the autonomy for our model, and the external repression, and it can represent the dangers of neighbors of the society. And we have the mutual policing. It is the thing that we use as on the Frank model to make an internal repression inside the group, which means to help the group be more cooperative. We also have the fitness function and the power. Okay. So for the polity characteristics, each polity in the model is defined by a binary vector, which has traits. So each trait may has a 1 or a 0. The value of 1 means a desire is fulfilled, while 0 represents the repression. The average of those values is how the traits indicate the polity's level of autonomy. So if we have a high value of satisfaction, it means that it is a group that is not cooperative. If we have a less satisfaction, means it is a very cooperative group. As complexity increases, ones are transformed into zeros, which means to have a large society, we have to repress more individuals, which means our satisfaction will decrease. So this is necessary sacrifice for coordination. For the adaptive repression, so repression inside a polity isn't a constant. It's always changing in response to the outside environment. So it depends on the neighboring societies. So as those societies become more powerful, the pressure that forces the polity will get high. So whenever the external threat rises, we see more repression and stronger internal order. And this creates a feedback loop where outside competition that comes from neighboring societies drives the internal repression, which can makes the cooperation evolve on the group. And societies adjust their their internal structure based on their surrounding competitive environment. We have the fitness function. So on this fitness function, we have to make a trade-off. So the core of the model is this fitness function, which captures a trade-off. So increasing repression within a society really boosts coordination and group fitness overall. But, of course, that repression simultaneously imposes a measurement cost on individual autonomy. So while group performance goes up, individuals lose some satisfaction. So societies must balance and find a balance societies must balance collective benefit against the individual sacrifice if they want to make it for a long term on the world. So we have the fitness function, which is inspired by Frank's model. Here it is a function that we tried to talk about the bad effect of the external danger, like the sigma, and also the bad effect of being in a non-cooperative group, which is the second term, and also the first one, which gives a boost for the individuals that are cooperative more than the other individuals that are not cooperative. We have also the power function that depends on both the size and average fitness. So internally cohesive societies gain an advantage in conflicts. So if the society is very big and if it has a big fitness or an increased fitness, it's more likely that it will conquer other societies, and this power is the one that will say if an attack will be successful or not between the polities. For evolutionary dynamics, warfare acts as a selection mechanism on our model. Only the most cohesive societies tend to expand and persist. And cultural dynamics are always in play. We use mutation and assimilation. The mutation is where we can mutate a satisfaction vector, which means the autonomy of the individuals. We can make them more satisfied or less satisfied, just in a random way. And we have also the assimilation, which means when an attack is already done and it is successful, it's more likely that the attacked one or the loser that loses the attack may copy and assimilate the attacker. We see societies regularly cycling on our model through periods of expansion and then fragmentation. But with the growth comes fragility, and when we have big societies, we have the risk that this society will collapse, and so we integrated a collapse mechanism. For the geographical embedding, so to make our work seems more realistic, and so we can compare it to something that we have in the historical data, we used the work of Turchin that was published in PNAS. We used a lot of geographic characteristics that he used in his articles, so we can interpret our theory according to those characteristics. So we have here the agriculture, the steppes, the rivers, the elevation, and also the desert places, and also the spread of military technology. All of these characteristics they can make warfare more accurate in places or less, or make the defense of a society more big or their power so they can defend their societies. So those features shape interactions, defense, and cultural transmission. We did simulations. So my presentation is a little bit weird. I don't know why. It wasn't like that on my laptop. So for emergent patterns, as on the work of Turchin, we divided also the eras into three. The one without the text was the first era between 1,500 BCE and 500 BCE, where we were able to predict the Mesopotamia, Egypt, and China. This is validated with the historical data that we have on Turchin's work. We also have the second era that we were able to predict a lot of interesting areas like South China and the Mediterranean, and also in India, some places in India. And for the third one, it was also all the red areas and the yellow ones, and also we added some areas on Africa. So here I just want to say that the colors, the red ones, means that the places where we have a lot of big societies through history. It's the occurrence of big societies. For the yellow one, it's the last ones. So here I want to present our contribution. So we provide a macro-founded mechanism for the emergence of large-scale cooperation, and we explain how cooperation emerges from internal regulation under external pressure. For conclusion, so complex societies only emerge when they find a way to truly control internal competition, and achieving large-scale coordination always means some sacrifice of personal autonomy. And civilization isn't simply about people working together by choice. No, regulation is a fundamental process. And thank you for your attention. We had here, I don't know if it's gonna work, it's just a simulation of each screenshot represents a 100 tick on our model, so we can see how societies or how the occurrence of big societies were on our map. It's a small video. Yes, and thank you for your attention.